Hi. So today I just decided to practice the Cambridge IGCSE Computer Science exam on my computer, and I answered one of its questions in quite a really strange way, to be honest, but it's actually correct. So let's take a look at this weird answer I just got. So let's see. So the task is to draw a logic circuit which corresponds to the following logic statement, where x equals 1 implies that a is not 1 or b is 1 and c is 1, or b is not 1 and c is 1. That's quite a bit of jargon there, but so they asked me to draw a logic circuit that represents that. Now, obviously, this statement, I was thinking in my mind, hey, I mean, it can be simplified, right? So yeah, it could be simplified, and that's the simplification. It's just this one line. So A and B inputs are redundant, so they go away, and the the input C is the only thing that matters, and inside the machine is just C wired to X. So therefore, X equals 1 implies A is not 1, or B is 1, and C is 1, or B is not 1 and C is 1, is just the same as saying X equals 1 implies C is 1, or C is true. So why is this? How does this work? Well, to be honest, you're gonna need to take a look at the proof, and it requires a bit of knowledge on Boolean algebra, which should be quite easy. So this is the proof that I made. Actually, there's a more correct one. I have it on paper right here. There you go. So I fixed the that sign to the implies because I forgot that. Anyway, so when x equal 1, it implies that not A or B and C, or not B and C. Now prove that X actually implies C. So yes, so I'm actually proving, oops, I closed my laptop. Okay. Alright, I'm actually proving that this is true for this circuit. Instead of going around processing A and B, which takes actually a lot of computational time in terms of theoretical computer science, I actually made just C and wired it to X, because that is how you simplify your programs. It's good. So how exactly did I do that? Well, this is the proof. So it's the proof that that diagram is true. So let's read it out. So x equals 1 implies that not A or B and C, or not B and C. So this is the first statement right here, and that is just the identical statement as the exam themselves. Now we want to distribute the conjunction, or wait, what did I distribute? Yeah, I distributed the conjunction. So this conjunction and C is distributed into these two terms, or terms. So we have not A and C, or B and C, just like that, and then the rest of the terms, or not B and C. This is called the distributive property that the conjunctions have. So I've distributed them. Now what? Well, let's go on the next line. X equal 1 implies that not A and C, or B and C, or not B and C. Basically, that's just the same reading as the line above, and all I did was remove the parentheses because of the associativity property. Then we actually simplify, because we notice that not A, B, and not B, they just basically redundant, because B and not B, and then there's an or here, and then it's pretty obvious. Actually, I don't really know how I simplified this, but it's just like a gut instinct for me. And so yeah, so the only term that matters right now is that C be true, and that is the case. So x equal 1 implies that C be true, and quod erat demonstrandum. So that is the proof, and thus it has been proven. Now I did do some practicality on this by running this program using this pseudocode, exactly this one, typed it verbatim onto PariGP, which is a computer algebra system. I did that, and I also typed my code, my pseudocode, which is just this machine, x equals 1 if C. I did that, and the outputs are the same. Therefore, not only is the theoretical proof the same, but also the practical proof is also the same as proven by my my CAS computer algebra system. Now, do they accept this answer on the paper? I'm not sure, because take a look at this. So this is the answer key containing the answers they were expecting, IGCSE. As you can see, although my solution is correct, and there is proof, as you've seen before, it totally violates the mark scheme. With just a line drawn, there is literally no sensible place to put the dotted box. So they will give 1 mark per dotted section. Now, of course, if you draw redundant gates, you can of course draw boxes. But if there's just a line, it's already really just correct and simple enough. Don't have to draw a box. So I guess that is some cool thing. Now, yeah, and I put it on Imager. Yeah. Okay. So that's all. And basically what I'm saying is this amazing thing that this circuit right here is equivalent to this circuit. Just mapping C to X and it's done. It's quite amazing right now for me. I'm excited. Yeah. Okay, so bye.